Imagine this. You're sending an email, watching YouTube, asking ChatGPT a question, or searching on Google. Everything works instantly. But somewhere, hundreds or even thousands of kilometers away, a power outage suddenly occurs. A transmission line fails. A transformer trips. An entire city goes dark. You'd expect millions of users to immediately lose access to their favorite services. But that almost never happens. Modern Google data centers are designed to survive failures that would shut down entire towns. So how is that possible? How can facilities consuming as much electricity as a small city continue operating even when the grid fails? The answer lies in one of the most sophisticated electrical systems ever built. A system with multiple layers of redundancy, backup power, batteries, generators, and constant testing. And today, we're breaking down exactly how Google data centers never lose power. And if you enjoy this type of content, consider subscribing to Project Breakdown, because we break down the engineering behind the world's biggest projects every week. What is a data center? Before we talk about backup power, we first need to understand what a data center actually is. A data center is a facility filled with servers, networking equipment, storage systems, cooling units, and electrical infrastructure. These servers power everything from Google Search and Gmail to YouTube, Maps, and modern AI systems. Every photo uploaded, every email sent, every video streamed, every AI request. All of it depends on data centers. Modern hyperscale facilities can contain tens of thousands of servers and consume hundreds of megawatts of electricity. Some campuses use as much power as a city with over 100,000 residents. And that's why losing power is simply not an option. The biggest threat. Most people assume cyber attacks are the biggest threat, but the real enemy is much simpler. Power loss. Without electricity, servers shut down. Cooling systems stop working. Network equipment goes offline. Services become unavailable. And even a few seconds of downtime can cost millions of dollars. That's why companies like Google build their infrastructure around one philosophy: never rely on a single component. Everything must have a backup. And every backup needs another backup. Layer 1. Multiple grid connections. The first line of defense starts outside the building. Large data centers are rarely connected to just one utility source. Instead, they receive power from multiple independent feeds. These connections often originate from different substations and transmission lines. If one source experiences problems, another source remains available. Sophisticated control systems continuously monitor power quality and automatically transfer loads when abnormalities are detected. But utility failures still happen, which brings us to the next layer. Layer 2. Transformers and substations. Once electricity arrives on site, it enters the data center's own electrical infrastructure. Large campuses operate private substations equipped with transformers, switchgear, protection systems, and monitoring devices. High-voltage electricity is transformed into usable voltages for the facility. And once again, redundancy is everywhere. Multiple transformers, multiple switchboards, multiple distribution paths. This design philosophy is called N+1 redundancy. If one transformer fails, another immediately takes over. Maintenance can be performed without shutting down operations. But what happens if the entire utility grid disappears? That's where things become really interesting. Layer 3. UPS systems. The most critical component inside the facility is the UPS, uninterruptible power supply. Think of it as a giant battery system. Its purpose is simple: provide instant power when utility electricity disappears. And when we say instant, we mean instant. Not seconds, not milliseconds, immediately. Servers cannot tolerate interruptions. The moment utility power fails, the UPS takes over seamlessly. Users never notice anything. No interruptions, no blinking screens, no downtime. Modern hyperscale facilities use advanced battery technologies capable of delivering enormous amounts of energy in a matter of seconds. But batteries are only designed to bridge the gap. Eventually, another system must take over. Layer 4. Diesel generators. This is where the giants come in, massive diesel generators. Some are larger than city buses. When utility power fails, automatic controls immediately start the engines. Within seconds, they reach full operating speed. During this transition, the UPS continues supporting the load. Once generator output stabilizes, power is transferred from batteries to generators. The entire process is seamless. Most users never even realize anything happened. Large campuses operate dozens of generators, providing enough capacity to power entire neighborhoods. And they store enormous amounts of fuel on site. Additional fuel suppliers can continue deliveries during emergencies, allowing facilities to remain operational for extended periods. Redundant power paths. Generating electricity isn't enough. It also needs to reach every server. That's why redundancy exists throughout the entire distribution system. Most servers receive power from two independent sources: dual power supplies, dual switchboards, dual UPS systems, dual distribution paths. If one component fails, another immediately takes over. This philosophy extends to nearly every critical system inside the facility. No single failure should ever cause downtime. Testing everything. Backup systems are useless if they don't work. That's why data centers constantly test their infrastructure. Generators are started regularly. UPS systems are inspected and verified. Protection systems are tested. Transfer sequences are simulated. Commissioning teams intentionally recreate failure scenarios to ensure everything performs exactly as expected. Entire facilities undergo integrated system testing before going live. These tests verify that generators, UPS systems, cooling systems, switchgear, and monitoring platforms all operate together correctly. Nothing is left to chance. Why downtime costs millions. So why spend billions on all this infrastructure? Because downtime is incredibly expensive. Major outages affect millions of users. Businesses lose productivity. Financial systems become unavailable. Critical applications stop working. Studies have shown that large-scale outages can cost hundreds of thousands or even millions of dollars per hour. For companies like Google, reliability isn't a luxury. It's a necessity. Everything is designed around one objective: stay online, no matter what. The future. Artificial intelligence is driving unprecedented demand for computing power. New AI facilities require more electricity than ever before. Power consumption continues to grow. At the same time, operators are investing heavily in renewable energy, battery technologies, and advanced energy storage systems. The next generation of data centers may look very different. But one thing will never change. Reliable power remains the foundation of the digital world. Conclusion. Every search, every email, every video, every AI prompt depends on infrastructure most people never see. Behind the scenes, Google data centers rely on multiple utility feeds, substations, transformers, UPS systems, diesel generators, redundant power paths, and extensive testing procedures. Each layer exists for one reason: to eliminate downtime. So the next time you open YouTube, send an email, or ask an AI a question, remember this: somewhere, a massive network of engineers, batteries, generators, transformers, and electrical systems is working around the clock to make sure the lights never go out. And that's how Google data centers never lose power.